Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker, chapter 14, part 3, Cook's distance. All right. One reason that you might use Cook's distance is to test whether or not an observation is influential. And we're going to do this for every observation in your data set. Now, one reason that it's important to know if an observation is influential is because if a single point is driving your entire analysis, you want to make sure that that data point is correctly written down, and also B, what's the impact of that actual data point. So when you do this, first, you're going to calculate Cook's distance for each data point, right? So the test statistic for the ith observation is going to be, what is your prediction with the data point in the model versus the prediction without the data point in the model? So when you see that y hat j with those parentheses of I, that is the prediction of the jth observation from a refitted regression model in which the observation I has been omitted from the analysis, okay? K plus 1 is the number of parameters because K is the number of predictors, plus you have that intercept. MSE is our mean squared error. And the y hat j is the prediction from the full regression model for observation J. So essentially, what we're going to do is we're going to do this test for every observation, and we're going to see, are any of the particular data points influential? If the null hypothesis is true, then Cook's distance follows an F distribution. So we've seen the F distribution a few times before, right? It peaks at 1, is skewed right. We can set up our rejection region. We set up our fail to reject region. We set our alpha level. There's nothing special about 0.05. I'm just using 0.05 from convenience. But really, it should be based on your actual context of the problem. And essentially, we can calculate a critical value, okay? At the end of the day, for each of our observations, we calculate the test statistic and we find out whether or not the observation is influential. Now, I would say that you shouldn't just delete observational data points because they exist. However, if you have influential data points, you need to first find out that the data point itself is correct, that it was recorded correctly. This can be a way to easily find out if you have mistakes in your data. And the other thing that you should do is to say, if I have a single data point which is driving this analysis, maybe I'm in a situation where I need to collect more data. Because if one observation is changing the analysis that much, we don't want our interpretations of our results to be driven by just one single observation, right? So that's why it's really important to check for the Cook's distance. And this is one way you can do that. All right, I will see you guys in the next video.